So like I said, we're gonna go over every single one, regardless of how frequently or infrequently it was missed. I would advise you, couple things. First off, like after each one, when I say, hey, does anybody have any questions? Like, let's just try something new. Like, if you actually do have a question, like ask it. That's it's an idea whose time has come. So just raise your hand and you say, yeah, I don't understand what happened, and then we go over it. Yeah. Okay, we're gonna get to number 2 when we get there. I know. We're gonna do every single one. The other thing I would advise you to do would be not only because the ability to use a calculator is inherent throughout the quiz. That's one main reason for it. But number 2, from what I saw, some people, that is the issue. They just don't know how to put stuff in the calculator. We've tried to go over strategies of like breaking this into pieces. To like the more operations you have to type, the more times you have to hit plus, minus, multiply, divide, exponent, the more likely you are to make a mistake because you guys don't know how to do it properly. So like we talked about how to break it into pieces, how to do certain operations first, like let you control order of operations. We'll do the same thing here, but have a calculator out. It is a class material. I think it would be a good idea. I'll even give you an opportunity to type it in your calculator so that you can get what's on the screen. And if you don't, then you say something. So let's start off with number 1. What is the sum of the first 7 terms of this geometric series? In order to find the sum of a geometric series, what do you need? You need the first amount. That would be the most obvious one here of all. That's the 6. What else do you need? Common ratio. Maybe that's less obvious. What's the common ratio here? 7. Negative 4. And how can you tell that the common ratio is negative? The signs are alternating, sure. And if you're ever not sure, jump to a number in front and divide the number behind it. And if negative 24 divided by 6 gives you the same thing as 96 divided by negative 24. Gives you the same thing as negative 384 divided by negative 384 divided by positive 96. They all give you negative 4. And Landon, what's the last thing? I need the number of terms that was also given to me. That's that little subscript, the 7. Okay. When it comes to multiple choice, I know you realize that we're not really scrutinizing the work. I knew it. Always up to no good. So the sum of the first 7 numbers is the first amount. So look, this one wasn't bad. It was 88% of you, I think, got this one right. So that's a good sign. But if you got it wrong and you feel that you typically tend to know what you're doing, it was probably because of the common ratio. You got to be careful with that. So, what I was saying before. So like I know that you know that you don't get assessed on your work in multiple choice, but that doesn't mean you shouldn't have it. Now, the work that needs to be there is this, what you see right now. And later on when we do free response, that's what you were assessed on, is did you substitute the right numbers where they go? And then however many steps you have in between is up to you. But if you want to put that whole thing in the calculator, be my guest. I'd break it up into P. Like I know I can add that. That's going to give me 5. You cannot do the double negative on the top. Like if I were to break it up into pieces, put the top into your calculator. Put 1 minus negative 4 to the 7th. Or if you want to break it up into even less than that, just do negative 4 to the 7th. So see that you're getting a negative there. And then you can turn a double negative into a positive. So what is 1 minus negative 4 to the 7th? Should be a positive number. What is it? 16,385. And I know 1 plus 4 is 5. So at that point now you can just put it in the calculator. 16,385 divided by 5 and then times 6. I believe it should give you A. But everybody, for other than maybe like 6 of you, I think, something like that, we're okay with that one. What is 6? 1, 2, 3. Yep, 6. 6 people got that wrong. Hey, does anybody have any questions? Anybody not sure what I did there? Anybody that can't get that on the calculator? So we move on. Number 2, which I believe 24% of people got wrong. Jonathan, I'm not sure what type of question you would have here. The question is, does this represent a geometric sequence? Yes or no? Why not? There is no common ratio. In order to be geometric, there needs to be a common ratio. To get from one number to the next, you have to multiply. If you remember, we haven't covered it here, but if you remember anything from Algebra 1, what type of a sequence is what you're looking at there? Arithmetic, yeah, it's an arithmetic. Or arithmetic, as some people say. D. It's not geometric. You're adding. To get from one to the next, you're adding. That's arithmetic. Any questions there? Okay, 3 was one of the worst ones on the entire quiz. It was. I said one of, not the worst. One of the worst. Now, something interesting, though. Yes, you could argue that 3 was intended to be a trick question, but the trick, air quotes, would have led you to put that. Funny thing is, though, is as bad as it was, only 39% of you correctly put D. Even less people put A than put D, which what that indicates is you just got it wrong. You didn't get it wrong because you were tricked. You just got it wrong. You know, like if it would have been the trick that got people, there would have been an overwhelming amount of people that put A. But that's not the case. Less people put A even than put D. So in June, Corey begins to save money for a video game and a TV. Wow. All right, and he wants to buy that in December. Now that could be a little bit tricky because you're like, oh man, is he okay? Well, he's gonna buy it in December, right? So that we're not gonna count December. But if you keep on reading, it says he starts with $20. Each month he plans to save 10% more. That's what makes it geometric. Anytime you're increasing or decreasing by a percent, that's what makes it exponential, which makes it geometric. So he's gonna save 10% more every month. And how much money will he have at the end of December? So that means that we're counting December. He's gonna save in December. So here's where the trick should have happened. Here's where if you were gonna get fooled. How many months are there between June and December? Especially if you're counting December. Yeah, oh well, 12 minus 6. No. Some of you might like. I literally had people in first period counting with fingers. That's fine. In summation notation, you know how we do upper minus lower plus 1? That's going to come up now in a couple problems from now. Upper minus lower plus 1. This is where the plus 1 comes from. Yes, I realize December is the 12th month. I realize June is the 6th month. But that plus 1 that we see in that upper minus lower plus 1, that comes because it's when one of those numbers is inclusive. Since we're including December, it's 7 months. If this were intended to be a trick question, like that's what was supposed to trick people, and if that's the mistake you made, if you put 6 instead of 7, that would have led you to put A. But again, there wasn't that many people that put A. What is the common ratio here? I think that was a bigger issue. Yeah, people don't know what the common ratio is. It's 1.1, 10% more. 10% more than what we had before is the 1 plus the 10%. It's 1.1. And common ratio of first amount, that should have been the easiest one to identify, 20. So the sum that he would save after 7 months is 20, 1 minus 1.1 to the 7th over 1 minus 1.1. Break it up into pieces. Like if you got that far and you got it wrong, then your issue is a calculator issue. There's decimals, like, yeah, it'd be nice. You would minimize your chances for a mistake if you can tell me, like in your head, what's 1 minus 1.1? No. Negative 0.1. That's one less operation you have to type in. And guess what? Because of that fraction bar, if you're going to put that in like as is, if you're going to leave it as 1 minus 1.1, you got to put that in parentheses. But if you just do it in your head, you don't need a parentheses. So the question is, in your calculator, can you get it to come up with that? If you can't, say something, and I'll come to the rescue. I'll put on my cape and come to the rescue. I don't think enough people wear capes. Thinking about starting that as like a fashion statement. What do you guys think? Do like a cape? Come to school every day in a cape? I think that could catch on. Yeah. Not necessarily. See, if you're gonna put the entire thing into the calculator, then yeah, you'd have to put the numerator in a parentheses. You'd have to put the denominator in a parentheses. What I would do is I would do this. If it were me, I'd do 1 minus 1.1 to the 7th. I'd hit equal. Okay. Then I would divide. But since I know 1 minus 1.1 is negative 0.1, I would just divide by negative 0.1. But if you wanted to divide by what you see down here, then yeah, you'd have to put that in parentheses. And at the end times 20. Yes, sir. Because 10% more. 10% more. If you remember from exponential, it was 1 plus the rate of growth or decay. A 10% growth is the same thing as saying 0.10. 1 plus 0.10 is just 1.1. For a rate, if something was going down, if it was a decay, then your rate would be negative. Like if you were saying, oh, I'm gonna I'm gonna start losing weight, and I want to lose 5 pounds in the first month, and every month thereafter, I want to lose 10% more than the previous month. It would be 1 minus 0.10, yeah, which would be like 90%. Any questions there? Okay. 4 was surprising to me because I thought 4 was going to be like really bad. And not that it was great, but I mean, more people got number 4 right than wrong. So I don't know how much that had to do with guessing. And we did do quite a few of these. They want to know number of terms. I gave you several formulas for number of terms, but because what they're giving you here, there's no phone today. Because what they're giving you is the sum, I'm just going to use the sum formula. Just instead of like I'm going to use the one up here, but instead of putting sum, they're giving me the sum. So I would say 2, 4, 4, 6, 6, 7, 5 is equal to the first amount, which is 7. One minus the common ratio, which is 4 to the power of n. 1 minus 4. Now this one you can't just put into the calculator because the variable has not been isolated. You have to isolate the variable. Because the variable is up in an exponent, what are we going to eventually have to do? We're going to have to eventually do logs. Last week on either Thursday or Friday, we did like 3 or 4 of these back to back to back because I still remember the step that confused some people. The first thing you could do is like, what's 1 minus 4? Yeah, and I'm just trying to save space here. 1 minus 4 is negative 3. So I did it in one step. You could do it in 2 steps. You can multiply by negative 3 to get rid of that, and then divide by 7, or back when we did it, I just multiplied by the reciprocal times negative 3 over 7, and that's going to knock out this negative 3 down there, and it's going to knock out that 7 also. What is that? 2,446,675 times negative 3 over 7. Somebody with a calculator, tell me what you get. Jenny, you're slow today on the draw. 244,660. You're so I'm getting negative 104, whether it took you 1 step or 2 steps to get here, everybody needs to get here. That would give you 1 minus 4 to the n. What do I get rid of next? How? Minus 1 minus 1. So now I get negative 104.8576 is negative 4 to the n. This is now the step I warned you about. Yeah, you got to get rid of the negative first. Before you can do log, you got to get rid of the negative. Times negative 1 times negative 1. That gets rid of the negative in front. So 104.8576 is equal 4 to the n. Ezekiel is our resident log expert, so he knows now to take log base 4. And he also knows how to put that into the calculator. What property do we use to put that into the calculator? Change of base. I've seen some Casios before that let you just type in the 4 where the base goes, but I haven't seen one this year. And what do you get? Put this in your calculator. Make sure you can get it. Here's another question. Let's pretend this wasn't multiple choice. Okay? How do I know that the type of number I get has to be a whole number? Like if you're getting a decimal, how would you know that you made a mistake? We're looking for number of terms. If you're looking for a sum, yeah, a sum could be anything. When you're adding numbers, who knows what types of numbers you're adding? But if you're looking for a number, I can't have 10.47 terms. That doesn't make sense. So like I know I have to get an exact whole number, and that's what I do here. I get 10. Last call. If you don't know how I got that, say something. I will tell you what buttons to push on your calculator in what order. Yes, sir. Which step? That you change of base. So you would put log of the big number divided by log 4. Change of base. I just did it in one step. Like there, I took some liberties because we've done this before. What is 1 minus 4? Negative 3. So what most people would have done is just multiplied by negative 3 first, and that's fine. If you did multiply by negative 3 first, cool. That will get rid of the bottom. But then the next step you're going to do right after that is divide the 7 in front. So I just did it all in one step. If you multiply by negative 3 over 7, it knocks it out in one step. Multiplying by the reciprocal. Any questions? All right. I find 5 and 6 maybe to be the most interesting ones on the entire quiz. Because if you look at these, hey, they're almost identical, right? What do 5 and 6 have both in common? They're both asking you to find the sum of a series that's in summation notation. You know what's not similar? The percent of people that got it correct. What percent of people got number 5 correct? 73. What percent of people got number 6 correct? 16. Well, there's got to be a reason for it, right? Because these, at least appearance-wise, they look to be identical. Geez, why could that be? Well, maybe the instant knee-jerk response would be, well, hey, one of them is multiple choice and the other one is not. Okay? Well, yeah, but if that's the case, then multiple choice means that somebody could have just guessed or maybe copied. Fine. Maybe you add 25, 30%. Those two percentages are not 25, 30, 40% off. That's a, I mean, it's a Grand Canyon in between those two. So probably a better reason would be, and this is where I warned you, and I warned you about this, and I warned you about this, and what would you say would probably be the bigger reason why there was such a big difference here? What do we call that? What do we call that? The lower limit. I warned you about the lower limit and how it's important. You know, I told you not to just lull yourself to sleep. When you look at 5, on 5, the lower limit is 1. So what ends up happening? Yes, if you do upper minus lower plus 1, your n just ends up being what's up there. But if you did that for 6, you got it wrong. Okay? The other reason where the lower limit is significant is that's how you get your first amount. Here, when I plug in a 1 for the exponent, for the variable that's up there. What's 1 minus 1? 0. What's 5 to the 0? 1. And what's 2 times 1? 2. So your first amount here should have been 2. And the only other thing I'm missing is the common ratio. It's that should be the easiest thing to identify in summation notation. What's the common ratio for number 5? 5. It's the base. So if you can get that far, now it's just a matter of substituting. The sum of these 8 numbers would be 2, 1 minus 5 to the 8 over 1 minus 5. I think we've gone over these enough. I mean, if you have a calculator issue, let me know. I'm not going to write down all the steps. I'll just tell you that you should have ended up with this. If you can't, however many steps it takes you, if you can't get this to give you that, let me know now, and we can try to fix it. You can do 1 minus 5 on the bottom, 1 and on the top. Yeah, I like to break it into pieces. I would put this into the calculator first. Okay, 1 minus 5 to the 8th and hit equals. What would I be dividing by? -4, yeah, just divide it by -4, hit equals again, and then go times 2 and hit equals again, and that should leave you with A. 195312. This will be online, by the way, today. Quizzes I post. Tests I don't, but quizzes I do. Right, Isha? Good job, Isha. Any questions on 5? All right, so now let's look at 6. Well, there's a couple issues here. First, with a number of terms, because that lower limit is not 1, as long as you use the formula I gave you, upper minus lower plus 1, what is 5 minus 2 plus 1? Ooh. 5 minus 2 plus 1 is 4. When it comes time to find the first amount, I'm not plugging in a 1, I'm plugging in a 2. What's 2 squared? 4. And 4 times 6 is? I went over this entire problem last period, went through the whole entire thing, all the explanation, and then at the end somebody asked me, hey, how did you get 24? So if you don't know how I got it, if you're not paying attention right now, say something. Do you know how I got the 24? I plugged the lower limit in for x. And then Zeke, what's the common ratio here? 2, the base. The base is 2. I have everything I need. If you got that far, the rest is cake. Sum of these 4 numbers is equal to first amount, which is 24, 1 minus 2 to the 4th over 1 minus 2. And heck, you can do this one almost mentally, because I know 1 minus 2 is -1. 1 minus 2 to the 4th is -15. So -15 divided by -1 is 15. What's 24 times 15? I heard somebody when we walked in saying, oh, wait, what question was that, 361? Yeah, that was this one. It was the worst one on the entire quiz. No, Juan, you said you don't know how I got 360? You don't know how I got any of it. I gave you a formula on the notes that says that when you're in summation notation, the way that you find n is to do upper limit minus lower limit plus 1. Go ahead and use your fingers. What is 5 minus 2? You just said you lost me. I lost you at n. So now you got the n part. Okay? How do you get first amount? Anytime you're in summation notation, the way you get the first amount is to get the lower limit and plug it into the expression, what's called the explicit definition, to plug it in there. If I plug a 2 in for x, what's 2 squared? 4. What's 4 times 6? 24. It's not an x minus 2, that's an equal sign. I know it's a little blurry, but you should have known from all the ones before that equal sign's always there. It's just always there. And then you know where to find the common ratio? No? Can somebody help Juan? Or where do you find the common ratio? The base, whatever the base is, the number that's underneath the exponent, the base. That's always the common ratio. Do you have any issues? Once we do identify these, Do you have any issues with this? That part you got. Cool. Alexis, any questions for you? Edvin, you okay? All right, then we got into evaluating piecewise functions. This is as close to a freebie as we could have gotten. I really hope. Let me see. Let's look at the percents. Yeah, other than number 10, and even then 10 wasn't too bad, but okay. It looks like you guys took advantage of it. This also shows me that graded response is not the issue, because you should know how to bubble these. Now look, there's two functions here. One of them is called f and one of them is called g. Within each function, they each have pieces. So you got to make sure that you're plugging these inputs into the correct piece. So number 7, when it says f at 1, what piece am I plugging that into? Yeah, the 3x minus 2, because that is function f, and 1 falls into the domain of that first piece. After that, if you do this in your head, I can live with it. I'm not forcing you to write. 3 times 1 is 3, minus 2 is 1. The answer for that should have been 1. Just bubble a 1. The next input of 2, that goes into function f again, because it's f at 2. What piece within f does that fall into? The second piece. The second piece is a constant function. Anything that falls in this domain will have an output of just 4. That would have been your answer there. F at 3. What piece does that go into? Into what? Yeah, the last one, the third one. We're still in function f, but now 3 is included there. 5. Landon, you with us? This way, this way. 2 times 3 is 6. 5 minus 6 is negative 1. You would have bubbled the negative, you would have bubbled the 1. Now 10, this is, not that a lot of people missed this, but a few, this was the worst of the bunch. Maybe some people didn't know where they look at this and they're like, oh, gee, I won. Because see, these, the way it happened to work out, and I didn't do that on purpose, but, maybe people just thought to plug it in there. How many of you put 4 and are willing to admit it for number 10? How many people put 4 in here and are willing to admit that they put 4? The 1 is included on the bottom piece. It has the or equal to sign. So you're plugging it in for this x down here. 2 times 1 is 2. What's 10 minus 2? Any questions on anything on the first page before we move on? Julian, are you going to watch me on YouTube or are you going to watch somebody else on YouTube? Okay. So now these next two, 11 and 12, and these were pretty good too. And I didn't even realize this when I put this on here, but it basically give you the answer. I didn't realize that they had put the points there. But like what you're doing when you're evaluating on a graph, it says h at 1. You're almost looking just at a vertical line. You're looking straight down the 1 on the x. And where does the red touch the blue? When I put the line at 1 on the x, where does it touch? At 4. So that would have been 4. There just happened to be a point there. And, oops. And then at 2, so you bubble the negative and you bubble the 2. Landon, Caleb, questions, anything? So far, so good. All right, this one I did on purpose to try to get the guessers out there. Because if you're just not paying attention and guessing, right? This psychologist charges according to this. What type of function is that? Good, step function, because it looks like a steps on a staircase. And if you look, okay, 3.5 hour session. What two integers does 3.5 fall in between? 3 and 4. And if you look in between 3 and 4, which is here, we charge 340. Now the guessers out there then might say, well, but there's no way that they'd put the same answer twice. Why would we do that? No, that can't be right. I am 0% What'd you put? 340. Good. Yeah, it wasn't that bad. I mean, 86% and no. Well, the first one was worse. I didn't even realize that. So more people got confused by the 3.5 part than they did about the. I don't know if that's good or bad. Like I was thinking the trick was gonna be that we were gonna get you on that one, but guess some of you didn't know what to do there. 67% got 13. No questions? All right, so now let's go to the free response, and we'll also talk about points. So for 15, Justine earned $18,000 during the first year of her job at City Hall. After each year, she received an 8.6% raise. Find her total earnings throughout her 30-year career. So anytime you're increasing, you're raising by a percent. That's what makes it geometric. The keys here, and you did not get points for this. The first points were awarded by plugging it in. But let's identify. What's my first amount? 18,000. What is my common ratio? That was the one that killed everybody. 1.086. If you have an 8.6% raise, your common ratio is 1.086. And then what's n? How long are we counting? Over 30 years. So when you plug this in, the sum of all her earnings over 30 years is equal to 18,000 times 1 minus 1.086 to the 30 over 1 minus 1.086. This problem was worth 8 points in total. 6 of the 8 points came from here. You got 2 points for putting the 18,000 where it goes. You got 2 points for putting both of the 1.086 is where they go, and then you got 2 points for putting the 30 where it goes. After that, it was just based on the answer. However many steps it took you to get to the answer is fine. Because of all the decimals there, I can't really expect you to do smaller steps in between. If you know that like 1 minus 1.086 is negative 0.0086, that's one less operation you got to type in. You wouldn't have to do the minus on the calculator. But the last 2 points came from you putting the correct dollar amount. Is that right? Okay. We'll take Jenny's word for it. It's 2,277,657.74 Because it's money, we round to the nearest hundredth. The only variation, there was a few people that I could tell made rounding issues. Maybe they rounded too early up here. I had one person who rounded to the nearest dollar amount, even though it didn't say to do that. So if I could tell that you did it, you did the right steps, but you were off. Somebody put like 79 cents. I don't know why they do that, but I gave you one of the 2 points if it was just a rounding issue. That's 8 points. Of the free responses, this was the best. You earned more than half of the points available, but that's not saying much. Any questions there? All right. 16 was an interesting one. If you were here the day before, we gave you the answers to these. And the thing is, most of this was filled in. Hint, 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 hint. Something like this is going to show up tomorrow. It's not going to be as filled in. So just keep that in mind. Okay? Now, I don't know if this is a good thing or a bad thing or what. I'm not sure how to... but this was worth 6 points, right? So you got 3 points for this step correct, 3 points for that step correct. Let's jump to the last 3 points. Should have been, it was a giveaway. Why? It's just a formula, and it's printed on the quiz. The answer is at the top of the first page. The formula for sum is first amount, 1 minus common ratio to the n over 1 minus common ratio. So now the good news is that I think you guys realize that, so quite a few people got those last 3 points. The mess was up here. But and this is not going to be there all tomorrow. But they're telling you what to do here. They're telling you to subtract. What are they telling you to subtract? S sub n, which is the first line. That's what was given. And then the second line was after we multiplied that times r. And if you remember what we demonstrated in class before, on yours I bubbled it wrong. Just forget about what's bubbled. I corrected it, so you got the full. All those cancel out when you subtract. So what survives? The a sub 1 minus, because we're subtracting, a sub 1 r to the n. That was worth 3 points, but those 3 points were so bad that if you even got it close, a very common thing for some reason was people putting a plus there. Some people here with the r, they made the r look like an exponent, like they just didn't write that correctly. But if you got it kind of close, I gave you a point. I gave you one of the 3 points just for getting it somewhat close. And that was more just charity because everybody else had done it so poorly. We won't be as charitable tomorrow. Memorize the formula. You never know in life when you're going to need it. Any questions there? Yash, have you memorized the derivation of the formula for sum of a geometric series? So has Sophie. You think Jaden knows it? Is that what you guys talk about? Deriving sum of geometric series? That's what I talk to my friends about. Both of them. My friends. Alright, and then the last one. This one was kind of a complete mess in more ways than one. If there was like an America's Funniest Home Videos, but instead it was like America's Funniest Quiz Questions, some of the answers that I got here would have been, I mean, this was just all over the place. It was like guessing, but not even educated. Like some of the graphs we saw were just not good. Anywho, so this is a piecewise function. In order to graph, I think a big part of it is understanding what type of function is each piece. What type of function is the first piece? It is linear. So you can put as many points as you want. But what are the minimum amount of points? Like when I did it in class, 2 points is fine. Now, if you have 2 end points, like the middle piece does, well, those are the 2 points I would pick. But here, I only really have 1 end point, so I'm going to make sure that that's one of my inputs. And then for the other input, I can pick any other input that falls in that domain. Give me any number you want. Just make sure that it is less than or equal to -1. That's the only requirement. For my key, I picked, like, I wanted to get it all the way to the edge of the graph, so I picked -7. You could have picked -6, -5, -4, whatever you want. So Emily, let's do some substitution, like they do in the hood. What is -1 plus 3? Good. And then Edvin, what is -7 plus 3? Good. So the first point you got was for putting -1 for, if you put a point there, closed, it had to be closed because it's or equal to. If you put a point there, you got a point. The next point that you got was for, like, and it doesn't really matter what point you use here, but the line, which is what you see here drawn, has to be correct. It had to end up having a slope of -1. Again, the point I put was at -710, like that's what I had on my key. But this middle portion had to be correct. That gave you a point. Anything else you wanna? Stop throwing up gang signs. That's not good. That's only Hannah can do that in class. The last point came from the arrow, but I only gave you a point for the arrow if this middle portion was correct. If you just drew some nonsense down here and put an arrow, no. In order to get that point for the arrow, not only does it have to be the arrow, but you had to have received the point for the middle function. Like this line has to be in the correct location. If you put it at did you put an arrow? Then that's the thing. There has to be an arrow. You have to have an arrow. But in order to get a point for that, see, because like some people maybe did something like this where they put a point down here and they did that. Well, I'm not gonna give them the point for the arrow because the line is wrong. It has nothing. It's kind of like a combo point where you're getting the point. Not only like you have to show me it's going forever, but you also have to show me that whatever point you use there had to be correct. Like it's taking both things into account. Yes, Julian. No, negative 1, 4. Negative 1 plus 3 is 4. The next piece was the biggest disaster. That's where I'd say the best piece was the last one. The second best piece was the one I just did, and then the worst of all was this one in the middle. What word can be used to describe that piece? Quadratic. For a quadratic, for anything that has an exponent, I'd like as many points as possible, because if not, you won't be able to see the curve. Now, definitely the points you want to have there, this has 2 endpoints, so I definitely want to know what's going on at those endpoints. But what are some other points to try to help my graph? What are some other points I could have that fall in between negative 1 and 2? 0, definitely. What else? And how about 1? And that should be enough. If you can afford more, great. But for what we have, that should be good. Maybe we don't know what's negative 1 squared. Positive 1. Negative 1 times negative 1 is positive 1. Minus 2 is negative 1. 0 squared minus 2 squared minus 2 is 2. 0 squared minus 2 is negative 2. 1 squared minus 2 is also negative 1. Maybe one person got this piece correct. Like, this was really bad. This piece was, there were some people that got the endpoints correct. There were some people that got these correct, but then didn't correctly identify this as being quadratic. Emily, you're making me nervous. I don't know, like, is it really that important? Like, you want to do shadow puppets? I can do I can get my flashlight on my phone and we can do shadow puppets. And Miles, what's your favorite shadow puppet? The bear? I don't know how to do the bear. I don't even know how to do the dog. Arf, 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 like that. It looks a little bit like a Doberman. That's cool. I think you can do like a butterfly. So we needed what type of endpoint is going to go at negative 1, negative 1? Open. So that was a point. It had to not only be at negative 1, negative 1, it had to be open. What type of point goes at 2, 2? Closed. You got a point for each of those. If that's all you, because then what some, not a lot, but what some people did is they put that and they just connected the dots. Well, okay, I gave you the points for the endpoints. I didn't give you the points for what's in between. So 0, negative 2, 1 here. Try to make it curve, and now that's correct. So that's 3 points. 3 points for each piece. Each piece was 3 points. The last piece, it should have been the easiest one, and it was. For several people, that's all the points they got. What type of function is that? Constant, but you got to make sure if you look at the domain, that constant only exists when x is greater than 2. So here when x is 2, I go up to 7, where that's at. Caroline, you might want to stay for this. I'm almost done. And we do that. You got 1 point for putting the endpoint in the correct place and making it open. You got 1 point for the horizontal, and you have 1 point for putting an arrow at the end. So that's 9 points total. The question was worth 11 points. So how many points are missing? 2. That's going to be 1 for domain and 1 for range. Domain wasn't too bad. I wonder how much of it had to do with people just guessing. But the domain here, if I put a vertical line and I scan this with a vertical line, am I ever not touching the red? Is there any place that this black line can stop and not touch the red? No, this is defined everywhere. With arrows going in opposite directions, this is all real numbers. So I don't know how much of it had to do with guessing. Is we might as well just put a negative and a positive infinity, but that one people got right. The range was a disaster. Maybe one person got range right. That's, Caroline, why I told you to stay, so you can look at the range. Now, I want to believe that this has more to do with the fact that you got this middle piece wrong, that it has to do with people not knowing range. I think range tends to be harder than domain, but the thing is, if you got that middle piece wrong, you're going to get the range wrong, because that middle piece is the low end. It's the minimum. How low do we go? We go as low as -2. Do we touch -2? Yes, we do. Comma. How high does that piece go? Because now there is a gap. We have a gap in between here. We got to keep that in mind. So we go up as high as 2. Do we touch 2? Yes, it's closed. Union. When do we start up again? At 4. Do we touch that 4? Yes, it's closed. And how high do we go? Forever. That piece goes on forever. Positive infinity. So for that one, yeah, the two biggest issues were the middle piece and then also the range. No other questions for me? Caroline, if you can make it back in 3 minutes, you can go. Nah. Tomorrow test. The rest of your lives are at stake. You still need YouTube, Julian?